Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 3. This is Section 11.2, Problem number 3. It says, consider the function f of x equals 2x plus 5 when x is greater than 3, and x squared plus 2 when x is less than 3. Part A is a continuous when x equals 3. And we have to answer the same three questions we always answer for continuous functions. And part B is f of x continuous when x is 5. And again, you answer those same three questions. This is almost exactly like problem number 2. The difference is the or equal to that was in one of the inequality symbols is removed. You just have the top branch when the input is less than 3, and the bottom branch when the top branch is when the input is greater than 3, and the bottom branch is when the input is less than 3. So when we get to question 1, does f of 3 exist? Can I actually put in a 3 and find an answer? You can't. The top branch cannot take the 3 because it's only for input bigger than 3. The bottom branch can't take the 3 because it's only for input that's smaller than 3. So there's no place to put in a 3. So f of 3 does not exist, and right there I can stop. It's not continuous when x is 3. So for part A, not continuous. When x equals 3. I can actually find the limit. The limit will exist, but it doesn't matter. Once I get a no, I don't have to consider the other questions. Now, B is f of x continuous when x is 5? Now, it winds up being continuous. Since x is 5, the input is strictly bigger than 3, like the previous question. I can answer all three parts of my is this function continuous at this point question using only the top branch of my function. Can I put in a 5 and find an answer? Yes, I can. If I put in a 5, x becomes 5. 2 times 5 is 10, plus 5 more, I have 15. F of 5 equals 15. Yes, f of 5 exists. Does the limit of the function as the input approaches 5 exist? Yes, it does. It's also going to be 15. Again, I can just put in a 5 and find the answer. So the input, as I'm getting very close to that input of 5, the output is going to get very close to 15. So the limit of the function as the input approaches 5 is also 15. And the third question, does f of 5 equal the limit of f as the input approaches 5? Yes, 15 equals 15. They're both the same. So the answer to part B is yes, this is continuous at x equals 5. So is continuous at x equals 5. So it was not continuous when x was 3, but it is continuous when x is 5.